Have you ever noticed while driving around Minnesota in the summer, there are just miles and miles of fields? Did you ever wonder what's growing there? Depending on where you are, there could be many different crops, and one of those is most likely soybeans. Minnesota is a leading producer of soybeans. Our farmers grow about 7 million acres of this amazing crop every year. How much is 7 million acres? It's an area that's a little larger than the state of Vermont. So when you put that in Minnesota, you can see that it's a lot. 7 million acres of Minnesota soybeans produce nearly 300 million bushels of high-energy grain every year. Those soybeans are made into hundreds of different products for humans. They're made into soybean meal used for livestock feed, and they're also made into soybean oil, now used to make biodiesel fuel. Biodiesel fuel from dry little beans? Yes, that's exactly right. Biodiesel is a high-energy fuel used in diesel trucks, cars, and buses. In fact, most city buses and school buses use biodiesel. Other vehicles like mail trucks, road construction vehicles, and farm equipment also run on biodiesel. Biodiesel is great because it has fewer harmful emissions than straight petroleum diesel. That means it keeps our air cleaner and helps reduce global warming. Biodiesel is also renewable. Every year when farmers grow more soybeans, they're actually growing more fuel. Today you'll learn more about biodiesel as we tour a huge plant in Brewster, Minnesota. First, we'll visit with Terrell Anderson, the general manager.
We're here today at the Minnesota Soybean Processors plant here in Brewster, Minnesota, here to discover how they turn soybeans into a renewable energy source called biodiesel. I'll be visiting today with Terrell Anderson, the general manager of the plant, and he'll tell us how the plant works and more about biodiesel. How did this plant start?
Back in 1999, there were some farmers that met in one of their kitchens and decided they wanted to do something more with their soybeans than just sell them to the elevator. From that developed a 2,400 member farmer-owned cooperative that crushes soybeans and produces biodiesel.
How long did it take to build?
From about 2001 to 2003 was the construction period.
And who owns this plant?
The area farmers in Minnesota, Iowa, South Dakota, about 2,400 members.
When did the plant eventually begin to grow?
Back in 2003, they started crushing the soybeans, and in 2005, they started the biodiesel plant. And at this point in time, we're producing over 105,000 gallons of biodiesel every day.
How many jobs have you created because of this plant?
The plant currently has 80 employees, and it goes anywhere from the people that are loading and unloading the beans and the products, all the way up to the managers and myself in my position.
What do you see for the plant's future?
MNSP is looking at building a rail track that should be completed in December that will get our soybean meal down into Mexico, which is a growing soybean meal market. We're also looking at the possibility of refining our glycerin, which is a byproduct of our biodiesel, into a more value-added product that's used in more cosmetics, in the antifreeze, and adds a lot of value to our byproduct.
Where do all of these soybeans come from?
Our main concentrated area is northwest Iowa, southwest Minnesota, and some out of South Dakota. About 800,000 acres of beans goes through a year in this plant.
So what is biodiesel?
Biodiesel is what we produce from our crude soybean oil. We refine it into biodiesel. There is a surplus of soybean oil. The soybeans are crushed, the soybean meal is used for feed for animals. The soybean oil was a byproduct, and there was a surplus of that. And by refining it, we can produce biodiesel. Most of our biodiesel right now goes into the state of Minnesota for use with our mandate in Minnesota. We also ship to Florida, we ship to the East Coast, we ship down into Texas, and also California. It's a renewable energy source rather than petroleum diesel, which is not. We drop it into, it's blended with petroleum diesel and runs in diesel vehicles.
There are a lot of buildings at this plant. What is all done in them?
Well, in the largest, the tallest building there is the soybean processing. That's the preparation. From there it goes to the next building, which is soybean extraction, which pulls the oil out of the soybeans. And from there it goes back on the other side of the office building here, which has got the soybean oil refinery and the biodiesel plant.
Can we take a look inside?
Sure we can. Let's go. We'll talk to some more people.
The plant engineer will describe how soybeans are processed at this plant.
Have a seat.
Thank you. Can you explain to me how soybeans become diesel fuel for my bus, essentially?
Sure. There's actually 20% oil in soybeans. The other 80% is the meal. We take the soybeans, we prepare them for the process, we crack them, we flake them to make them very small so that when we add hexane, we can dissolve the oil in the flakes. Once all the oil is extracted from the flakes, it's ground up into our soybean meal, which is a main component for livestock feed and our main product here at the plant. One of the other products from crushing the soybean is our crude soybean oil. Take the crude oil, refine it and bleach it. There are many separation steps and distillation steps to go from the refined and bleached oil to the biodiesel.
Why flakes? I mean, it looks an awful lot like Frosted Flakes for breakfast. Why would you use that?
They do look like Frosted Flakes. They don't taste very good though. However, we flake them so they're a certain thickness so that the hexane, when added, will filter through the bed of flakes and extract the oil from the flakes.
I see, but hexane is a gas. Why would you use gas with the flakes? How does that produce biofuel?
Well, hexane in this instance is a liquid, and it has a property that the oil is soluble in the hexane, so it easily extracts the hexane from the flake, and then due to the nature of hexane, it's easily separated from the oil when we distill it.
There's a lot of chemistry and engineering involved, as it appears, isn't there?
Yes, there is a lot of chemistry and engineering involved to go from your refined and bleached oil to your end product biodiesel. As a chemical engineer, this is a very exciting process for me. There are many reaction steps in which we add catalyst and methanol to the refined and bleached oil. There are many separation steps where the biodiesel separates from the glycerin, and we have very many distillation steps where we separate the methanol from the glycerin, the methanol from the biodiesel, and the methanol from the water. We use distillation steps to reclaim the methanol so it can be reused in our process.
You also mentioned methanol. How is that important to the process?
The methanol is used to break down the triglyceride or the fat and allow the reaction to progress to the methyl ester, which is the biodiesel.
What is your educational background to work in a plant like this?
Well, I was very interested in chemistry and other science courses in high school. My background is chemical engineering from Michigan Technological University. I use my engineering background to help with processing problems, whether it's pumping issues or heat transfer issues or any other problem that might arise here in the plant.
Do you get any other products besides oil and meal from the soybeans?
There are. We try to use as much of the bean as possible. Hulls is one of the byproducts, which can be used as a livestock feed. Glycerin, which can be used in toothpaste, shampoos, etc. And fatty acids, which can also be used as a livestock feed.
Almost 100 people work at this plant, and the biodiesel produced here helps fuel vehicles and machinery across the Midwest and around the country. Now we'll step into the control room and see how this plant is operated.
Okay.
Okay.
Yeah, it's hot out here because the oil's 245 degrees.
Oh my gosh, 245 degrees?
Yeah.
Is every single one 245 degrees?
No, not everything, but most of the oil is.
So what
that way.
essentially goes on in the control room?
This is the biodiesel refinery control room here. What goes on in here is we have two operators. They're operating the refinery and the biodiesel plant. What they're doing is both plants are fully automated. They are making sure that they're making quality oil. They run their samples back over here to ensure that they're meeting the specs that we're looking for.
So do they watch the same screen all the time, or are there different aspects of the computer they go to, or?
Yep, it's basically run through a block diagram system. The screens, there's 5 screens for the refinery, and there's 13 screens for the biodiesel building. And what they do is, from start to finish, they'll scroll through the screens, making sure that all the parameters are in check, and when they get out of balance, there are certain alarm set points. It'll sound different alarm for different building, and then they can go back and they can trend to see where it went wrong, what's going wrong, and how to correct it.
So if something were to go wrong in the plant, would the whole computer shut everything down?
Well, there are certain things that are interlocked when they get alarms and certain set points. Basically safety reasons, a lot of it. They're interlocked, so if one thing goes wrong, it shuts other things down. And then depending on the severity of what is going on, yes, it'll shut the plant down. And they can control all that from right here too.
I see you have some beakers here and other scientific equipment. Do you do other testing in this room as well?
Yes, we do. The operators, they run tests throughout the process all day long, every about 2 to 4 hours, to make sure that the quality stays in the guidelines, the specifications that we're looking for per customer specs.
So what do the customers expect? What are the specifications?
Well, they are looking for moisture. There's a flash test we do. There's a phosphoric test and the RB oil that we do. And a lot of the testing has to do also with the RB quality being good enough to produce good biodiesel.
And then do you just have 2 computer operators, or are there more throughout the plant?
No, well, there's more throughout the plant for other parts of the plant,
Yes.
but for
this
the biodiesel in the refinery, it's just 2.
I see.
And then there's Dan, he's a biodiesel supervisor.
Hello, nice to meet you. So what do you do as a supervisor in the biodiesel control
I
room?
just cover the day-to-day operations in the plant just to make sure everything's getting done and quality's being met.
So what kind of education is needed to operate a plant as vast as this one?
My educational experiences are mostly on-the-job training. This company here is real good at sending us to classes, Texas A&M University, seminars, just to continue our education. I do have some previous experience working in the ethanol industry before I came here.
Investing in plants like this is important for Minnesota's economy. Money spent to operate this plant puts millions of dollars into our state every year. Now we'll get a look inside the quality control lab.
So what is your name and what do you do here at this plant?
I'm Lyle Oberlo, and I'm the lab manager here. And what I do is I oversee all the testing that is performed, both in the oil side and the dry product side that we have here.
Great, so if I wanted to work in this lab, or if anybody else did, what are the qualifications needed to perform these tests?
We look for somebody that has at least a 4-year degree, and then prefer somebody with a science background.
So is this lab more of a product testing lab or a quality control lab?
It's a combination of the two. We are ensuring that the quality of the product leaving the facility is fit for use, but we also have like the daily samples. What you're carrying there is an in-process sample also. So it's a combination of the two.
So essentially here we have biodiesel, which is one of the main things you produce. What kind of testing do you perform?
This sample here that you're carrying is a finished product. It means it's ready to be used in a blend with diesel fuel. Testing, we have to do the cold filter soak test, which is right in front of us. And the importance of this is to ensure that the product is not going to gel when you're out in the field. One of the instruments we use for testing is a gas chromatogram. What we get is a printout from it. The sample is taken out of this sample tray here and injected into the inlet here. And as the gases, or as a sample is running through here, it goes through a column that's in here, and through the heat at different points of the sample going through, you have your different properties that come off onto the printout. The first ones we have is the glycerin right here.
So what does all of this mean in terms of a finished product?
The lower your numbers here typically gives you the better product. You have less impurities that would be causing issues in an engine. There's new air emissions control on vehicles and stuff. They're getting a lot tighter, and some of these components could possibly have issues with the motor, but as long as you keep these lower numbers, there's no problem.
So which of these mechanisms performs titration?
Each one of these do, but one of the particular tests we do is soap, and we will take a beaker like this, weigh it on the scale, zero it out, and then bring the sample, weighed sample over to here, and put one shot, which is 50 mils of sample in there, and if it turns yellow, or if it turns green, it tells us we have soap in our product.
So why would you want soap in your product, or why wouldn't you want soap in there?
Soaps are basically cause issues with your engine performance, so you don't want any soap in there for biodiesel.
Running this plant requires a lot of people, and all those people are focused on job safety. We talked to Molly Getzel, who told us all about her role as the safety manager.
I understand that there's around 80 employees who work at this plant, one of them being a safety manager. Why would a safety manager be needed at the plant?
Well, we run 365 days a year, 7 days a week. We run all shifts. So what we do is we try to anticipate any injuries or incidents that could happen to our employees. We want to make sure that we're protecting them and they're going home in the same condition they came in every day. There's all sorts of different hazards at a facility like this. We have heights, we have traffic, we have chemicals. We're using lots of different chemicals for reactions, and we need to make sure our employees know what to do to protect themselves from that. We need to follow the OSHA regulations and the rules. We try to engineer those hazards out as often as possible, and if we can't, then that's when we introduce protective equipment like hard hats and steel-toed boots. For chemicals, we use respirators, so we're not breathing in hazardous chemicals. And we need to make sure that our employees are aware of that, and that's where my job comes in.
How did you get your job as the safety manager?
Well, I was going to school for psychology. I have a degree in psychology. That when the plant started up, I started in the lab. We didn't have safety 8 years ago. We didn't have a safety manager. Everybody just kind of separated it between themselves. And I just took an interest to safety, and I got promoted into that.
Biodiesel is a great example of using a renewable and sustainable resource to make fuel. Minnesota soybean farmers are fueling the future.
How is biodiesel used in Minnesota?
The petroleum diesel sold in Minnesota has a 5% blend of biodiesel. Biodiesel is a clean burning fuel. It reduces the emissions from the buses, the cars, everything else, diesel burning vehicles. The emissions reduction is equivalent to removing 55,000 cars off the road in Minnesota every year.
How much energy does biodiesel produce?
Biodiesel produces 5.5 times the energy that used to produce it, so it has an energy ratio of 5.5 to 1.